know everybody's tired. Good morning.
Good morning.
I'm a teacher. I'm delighted to be here to talk to you about something very important to all of us. In fact, when I say Common Core state standards, I want you to tell me what you think of. What comes to mind? What are you hearing? What are the fears? What are the teachers saying? What are administrators saying? What does Common Core mean to you all? Just raise your hand. What is it? Yes, sir.
Aligning grade levels.
Aligning grade levels? Okay. Anybody else? What else does it mean? Yes?
Focus and depth.
Focus and depth. Absolutely. That's what we're hearing. Fewer concepts, more time on task. What else does it mean?
National standards.
National standards. And we're going to talk about that in the word national. What else does it mean? How about fear factor? Okay, everybody's afraid to say it. I'm not afraid to say it. There's a fear factor. Oh my gosh, we're changing again? You got to be kidding me. Well, that's one of the things I want to talk about. Why should we change? I love this cartoon. Entering Belltown, founded 1856, altitude 752, population 7,800, total territorial. What is that a total of? Absolutely nothing. The children say when they see a problem and there's 3 numbers in it, there's nothing you can do with them except add them up. Problem solving. Problem solving is why we teach math. But because these kinds of things happen, we have to look at how we're teaching it and what we're doing. So how many of you have heard about TIMS study? Yeah. How many of you think we're just in the toilet when it comes to the rest of the world? Because that's what they tell us. Well, I'm going to show you that that's not exactly true. Because this is what started the revolution. This is taken from page 8 of the TIMS study. And what it does is it shows you the test scores in the countries that participated in grade 4 and grade 8 in 1995 and 2007. And this last column is the most important because what this looks at is how much the states improved or went down or sort of stayed the same. And so when we look at this, we find out that at grade 4, Hong Kong had the highest score and they had improved by 50 points. England had improved by a greater margin, but they also had the lowest score, so they had more room to improve. Well, when we look at the United States, here we are, we improved by 11 points. And then when we look at grade 8, number 1 was Korea with the highest score, and they improved by 17. Colombia, look, they improved by 47, but they were still low. But they really did improve, okay? And then you look at the United States, we improved by 16. So when we look down here at those that went down, something is very important. We see that countries like Singapore that we hear so much about actually went down 16 points in 8th grade. They went down. What happened in the United States in our focus in teaching mathematics between 1995 and 2007? Did anybody recall? Anybody as old as I am? Yeah. When I first started teaching, we didn't even call it math. We called it what? Arithmetic. Those of you who answered, I know how old you are. Yes, in fact, if you taught primary, you spent the first 2 weeks of school teaching the kids how to spell it. A rat in the house might eat the ice cream. Don't write that down. Everybody says, oh, that's cute. But it changed to math because it wasn't just arithmetic that we were teaching. We were teaching mathematics. We were teaching problem solving. Our focus changed from just teaching arithmetic to problem solving because that's what we use in the real world. I mean, be real. You're not going to be walking down the street and somebody's going to say, quick, what's 6 times 3? No, that's not what we're doing. We're doing problem solving. But this was very interesting because while we still have room for improvement, absolutely, no doubt about it, we're not at the bottom. And I think that's very important for everybody to know. Because of that report, the National Math Advisory Panel was formed by President Bush. And Dr. Skip Fennell was on that panel. And what they did was look at what we're doing in the United States, looked at what other countries were doing. They looked at research. And what's very interesting was that they looked at a study that also analyzed all of the grade level expectations in all of the different states, and where were we with that? Well, when you look at this, Florida, look at the strands are number and operation, geometry, measurement, algebra, data analysis, probability, and statistics. That's how everybody organized their standards throughout the United States. And Florida won the prize at 89. Are you kidding me? How are you going to teach 89 expectations in 1 year? The answer is you're not. You may, but you're not going to do it well for any of them. And then you look at North Carolina, they were the lowest at 26. Think about this child who moved from North Carolina to Florida. They're in deep sneakers because they're probably going to have to go back a year. All right? Look at where we were in the United States, all over the place with the number of grade level expectations. And then everybody comes to the publisher and says, how come you have such a big book? This is why we had such a big book. Because we had to cover every single standard of every state in the United States. It wasn't because we wanted to, but we had to cover all of the standards. So the National Math Panel says, whoa, we've got a problem here. This is a big problem. Well, at that time, NCTM, and Dr. Fennell was president of NCTM, said, let's look at what we can do to provide some guidelines. And so at that time came the NCTM curriculum focal points. How many of you have heard of the focal points? Oh, a lot more, yeah, great. What this said is let's look at K-8 and identify the 3 areas that we believe at each grade we need to focus on. So this was the beginning of having more focused curriculum, fewer tasks. This became the foundation for what is now the Common Core State Standards. In fact, those 3 focal points became the 3 critical areas originally in the first draft of the Common Core State Standards. They went out for review. Anything that is, going to be this significant has to go out for review for everybody, all of you. Some of you probably gave input and read it and said, oh gosh, why are you doing this? Big comments. And so they changed those focal point areas, which are now critical areas, became 2 to 4 critical areas. But this was the foundation. This was the beginning of saying, okay, we need to have more focus. So the Common Core Standards, I said, well, how are we going to make this happen? Because of states' rights. All of the other countries, when you hear about their scores, they have national curriculums. Notice, ours is not called a national curriculum. Because if you did, you had to change the Constitution of the United States. So it is called Common Core. So it's common for everybody, but it is not a national curriculum. But if you're going to make it happen, who has to have buy-in? The governors, right? States' rights. Oh, Massachusetts, we're already doing great. Why would we need to do this? And Massachusetts was doing great. You did have great standards. But we needed to still bring everybody more in alignment so that everybody was doing great and doing the same kinds of things. So that when that child moved from North Carolina to Florida, they didn't go down a grade. In fact, I experienced that with my 2 daughters. My 2 daughters are now 42 and 40. And we moved every 2 years to a different state. And in one state, they want to move them up a year. In another state, they wanted to move them down. It became the most frustrating thing I ever went through. So I experienced that. We lived in 8 different states. And it was different in every single state. So we needed to have that commonality. But to make it happen, you better get the governors involved and get them to buy in to actually saying, okay, we've got to move this forward. And so the National Governors Association and the Council of Chief State School Officers were the ones who were the guiding force behind Common Core to say, okay, this is what we're going to do and this is how we're going to make it happen. How many states have bought into the Common Core? Which ones haven't? Do you know? Texas, bless their hearts, they still want us to secede from the Union. The funny thing is they do have new standards, and they're very, very close to Common Core. They just approved, the state board just approved them a couple of weeks ago, and their goal was to be better than Common Core. No surprise. We all think, yeah, right, okay. What other states? Alaska, but Anchorage just adopted Common Core. And the reason I know is because my children live there, and she sent me an email. She goes, Mom, look, we're going to get Common Core. Of course, Anchorage is mostly Alaska. Anybody, anything else?
Montana.
Pardon me?
Montana.
No, Montana's now on board. Virginia? Okay. Anything else? Yes.
Did Minnesota go with the literacy Common Core?
Yes,
and
they did.
mathematics? They have not.
Correct. Exactly right. So, I think when it all washes and comes to, you know, in the end, yes, and Nebraska. Good old Nebraska. Yeah, forgot about Nebraska. But the reality is, almost everybody is bought into Common Core. Okay? And it's because of these governors. So the goals of the Common Core state standards are focused and coherent curriculum. We were all over the place, as you can see, with all of those different objectives, everywhere. And so you need to focus on fewer concepts and be more coherent. Conceptual understanding, developing that understanding. Includes rigor and higher order thinking skills. It is not regurgitating back to multiplication tables. It is not how fast you can multiply and divide. It is understanding what you are doing. Align with college and work expectations. Every single job requires mathematics. You all used mathematics this morning before you came here. You got in your car, you looked at your gas gauge, and you estimated whether or not you had enough gas to get here. Right? Gotta look, oh yeah. The empty seats are those who are really bad at estimation. Right? They didn't estimate right. We all use math. I had a 7th grade young man tell me that he didn't need math. And I said, why not? He says, because what I want to do when I graduate from high school is be the manager of Burger King. And I said, good, go for it. I said, but did you know that in order to figure out how many hamburgers and how many hamburger buns that you need for 6 months, you have to solve an algorithm? He says, get out. I said, you better stick with the math. Okay. Every single job requires math. Think about that cashier at the grocery store who can't give you change unless it comes up on the cash register. Every single job requires mathematics. Internationally benchmarked. The National Math Panel looked at what other countries are doing and seeing, you know, the results, identifying. Look at the number of students that enrolled in our colleges right now in engineering, math, and science. And how many of them are from foreign countries. We have found that those are the kids that are enrolling from other countries and then going back to their countries. And then we have a work pool that isn't big enough to fulfill all of our needs. We need to make sure that our kids can compete internationally. Based on research, the National Math Panel said everything that we do needs to be based on research. Not just because I like it, I've tried it, this works. It has to be research-based, to make sure that there is proof that what we're going to be asking the kids to do and teachers to do actually is based upon research. Now I'm going to show you just a few grades, and not everything that is new and not everything that is gone as far as content goes. And if you're interested in the whole list, we have a document. I can provide it to you. I'll give you my email so that you can see and get a big picture of what is there and what isn't. New in grade 2, expand addition and subtraction strategies. Not memorizing them. You memorize for the moment, not for long-term understanding. So expand those strategies. Expand place value. Place value, the most misunderstood concept in mathematics. We always spent chapter 1 on it, right? You know exactly what I'm talking about. It was always chapter 1. Okay, let's get through that tuppy and then move on and get to the real stuff. We've never spent enough time on place value for understanding. Expand mental addition and subtraction. You all teach yourselves mental strategies. How do you add 9 to a number mentally? Absolutely. 8, 10 minus 2. There are all kinds of number strategies that we need to help the kids understand. Expand addition and subtraction of 2-digit numbers. Expand geometry. What is the key word there? Pretty easy to see because I highlighted it. Expand. More time on understanding fewer concepts. Expand time graphs and data. What's gone? Repeated addition. We're not going to be talking about multiplication. Okay? Money. Oh my gosh. Time, money, and calendar. Oh my gosh. Kindergarten. Oh, that's heresy. You know, it's gone. What am I going to do? Calendar time is my math time in kindergarten, right? Negatory. I want you to think about the calendar for a minute. I taught kindergarten. I did calendar time. The kids come in the morning. Good morning, children. How are you? What day is it today? Tuesday. They say, right. Let's find that on the calendar. Now, let's look again. How many days are in our school week? 5. And how many days on the weekend? 7. Okay, 5 and 2 is 7. That's good. Our number system is base 10. It's okay to talk about it for counting and more and less, before and after, and those kinds of things. But we were making calendar time our math time. I keep telling primary teachers, it's okay to do calendar time, just don't make it math time. You've still got to do your mathematics. Because mathematically, they are not mathematical concepts in and of themselves. They're things that I can use for applications. Skip counting for money. Okay. All of these things are applications, not math concepts themselves. And I know that's a tough one to get everybody to buy into. Even in odd numbers, patterns. Oh my gosh. Red, blue, red, blue, red, blue. Cute, cute, cute. That's not the kind of patterns that we need to be talking about in mathematics. Okay. We're going to talk about numerical patterns, looking at hundreds charts. I was with one of my granddaughters, and we do math when I go visit. They're so happy to see me. Okay, there's a hundreds chart, and I showed it to my granddaughter. I said, what do you notice? And she started looking. I said, look at the last row of numbers. She goes, oh, there's a 0 after every one. I said, right. I said, what does that mean? She goes, oh my gosh, 10, 20, 30, we're counting by tens. I said, so if I move over, if I have 31, what comes next? She goes, oh, 41, 50. Oh my God, all kinds of things. Those are the kinds of patterns and the numerical patterns that we need to look at. Fractions. Why did we do fractions in primary? We never went anywhere with it. Yeah, this means 1/2, so what? Why? Some of the things that we were doing were just to fill time, just to say we were doing fractions there. But was it really doing what we needed to do for understanding the fractions? No, it wasn't. So we did not need to do it. And there's that time, oh my gosh. New at grade 4, fluency, multiplying by 1-digit numbers. Fluency is a key word. Fluency is not equivalent to how fast can you do it. Throw away the flashcards. Throw away time tests. It's not how fast it means, do you understand it so I can build on it and apply it to something else. Fluency means I really understand the concept, and therefore I can build on it. Fluency with multiplying by 2-digit numbers. Fluency dividing by 1-digit divisors. Extending fraction concepts. The word there was fluency. Fluency means the buck stops. Here you've got to know it. Okay, very important. One of the problems with our curriculum was, for example, grade 3, multiplication and division facts. Well, that's okay, honey. It's all right if you don't get it now because you're going to see it again in 4th grade. Right? I'm not too worried about it. And you're going to see it again in 5th grade. And then we're going to review it again in 6th grade. So then the algebra teacher is saying, how come the kids don't know the basic multiplication and division facts when they come to algebra 1? There was never a point where we said, it stops now. You got to know it. Can't go on unless you do. Fluency means total understanding, and we're going to know it. Gone. Fluency with the standard algorithm for multi-digit whole numbers. It's now in grade 5. Operations with decimals, which now these teachers are really happy. That's gone to grade 5. Probability. Transformations. Stem and leaf plot. When was the last time in the real world you made a stem and leaf plot? I want to know. Not today, tomorrow, or the next day. Give me a break. Really? Area and perimeter, grade 3. Volume, grade 5. Now you're starting to see a trend in moving concepts around when we get to the upper grades. Okay? Bringing it down or up to a grade where we can focus on it. Okay? New at grade 8. Now this is where you're going to see a major change. Work with radicals and integer exponents. Woo! Analyze and solve linear equations. Define, evaluate, and compare functions. Understand and apply the Pythagorean theorem. Investigate the irrational number system. Oh my gosh. Heart failure for 8th grade teachers. Yeah. Middle school, 6, 7, and 8. Huge change. Huge focus also, and you're going to hear from Dr. Fennell, fractions. Fractions, 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 fractions. There's all kinds of research that talks about children flunking 9th grade algebra. They're not having a firm understanding of what fractions really mean. It actually starts down in the primary grades with composition and decomposition of number. Understanding number is the beginning of equivalence. Primary teachers also in writing a number sentence. 2 plus 3 is 5, is what you hear. No. 2 plus 3 is not 5. 2 plus 3 is equivalent to 5. There's a difference in the language, and you're going to hear about that from Dr. Fennell. Very important. One of our problems is, as primary teachers, and I was one of them, we tend to teach math like we teach reading and writing reading sentences. And so the translation for equal, right? Right, becomes is. Do you know that one of the things that we did that we got the most negative letters on was when we put 5 equals 3 plus blank? Do you know how many letters we got saying, oh, there's a mistake in your book, you put the equal sign on the left side? Oh, really? Oh my gosh. Equivalence. Children do not understand what equivalence means. Composition and decomposition of a number, kindergarten. We start teaching algebra in kindergarten with that. How many different ways can you make 10? How many different ways can you make 7? All of that, very important. And so when we get to grades 6, 7, and 8, where there's a larger focus on things such as this is pre-algebra. Notice with the Common Core, there is not a course called pre-algebra. There is not a course called algebra readiness. Grades 6, 7, and 8 are those courses. Over the years, we've watered down the curriculum at 6, 7, and 8, and so then there was a need for a pre-algebra or an algebra readiness. Not anymore. This is algebra readiness, so that every child, because every child in the United States is going to take algebra. And it has to happen. The readiness has to start in kindergarten and go all the way through 8th grade. What's gone? Fluency with operations of fractions. Now it's in 6th grade. Fluency with operations of decimals. 6th grade. God bless 6th grade. Formal study of perimeter. Now in 3rd grade. Formal study of angle measures. Now in 7th grade. We never spend enough time on angles either when we talk about geometry. So what you're seeing now, when we looked at just those 3 grades, expand time, that's a big word, on certain concepts. Fluency means the buck stops here. The kids need to really understand it because we're going to build on it now. And then moving the content around so that that grades 6, 7, and 8 really are strong content grades for pre-algebra, getting the kids ready for algebra in the 9th grade. So how are the Common Core standards organized? I'm sure you've seen this. Notice it says domain, number and operations base 10. That's nothing different than the mathematical strands, the way every single state has organized their standards forever and always, okay? It's a new document, had to have a new name. Domain means basically the same thing. Then you have got clusters of standards, and the standards are what the kids are tested on. So that's the organization. You know, very familiar to what we've always been doing. The content domains, grades K2 and grades 3-5. This means that the highlighted one, counting and cardinality, is only in K, and number and operations fractions begins at grade 3, not at grade 1. Fractions do not begin at grade 1. This is a very interesting chart because it shows you the number of standards for each of these at each of these grades, and therefore the total percentage of time spent on it. And of course, counting and cardinality is only in kindergarten. That's 5% of them. But look at this. Number and operations in base 10 for 19% for K2, 17% of the standards at grades 3-5, which makes sense. Because at those lower grades, I want to be spending more time on that. Number and operations fractions only happens grades 3-5. Look at that, 31% of the standards on that. Whoa, so what are we focusing on? Fractions. Helping the kids understand. Measurement and data, 26%, geometry, 12. Grades 6, 7, and 8. Ratios and proportional relationships, only in 6, 7, and 8. Functions, only in grade 8. And then all the others are the same. I've had so many 8th grade teachers say, functions? Really? Well, if we've got the foundation, the kids are ready for it, and they need to have that understanding before we go into algebra. Same kind of chart. Look at ratio and proportional relationships. 6 and 6 at grade 6 and 7, 15%. Number system, 21%. Expressions and equations, 23%. That's the bigger kahuna right there. Expressions and equations. Getting the kids ready for algebra. Okay? Functions, only grade 8, 15% of the standards. Geometry, 19, statistics and probability, 21. So that gives you an idea of how much time we'll be spending because of the number of standards. Common Core is made up of two things: mathematical content and the mathematical practices. The content of the standards that we're going to assess, but the practices are the things that we want kids to be thinking when they solve the problem. And if I combine those, then I get the understanding. Key word, if you don't get anything else out of my talk today, is understanding. Not doing, but understanding the mathematics. If you don't understand a concept, you can't build on it. And that's what mathematics is all about, is building on previously taught concepts. The mathematical practices describe varieties of expertise that mathematics educators at all levels should seek to develop in their students. When a child is solving a word problem, I want them to be thinking to themselves, does this make sense? Could I solve it a different way? Ooh, if somebody asks me to explain it, can I? Those are the things we want kids to be thinking about. They're based on two documents, the NCTM process standards and the strands of mathematical proficiency in adding it up. So I'm going to show you, and in parens are my little Heloise's helpful hints here to help clarify a little bit of what they're really asking for. Make sense of problems and persevere in solving them. What that means to the child is, can you explain it? Can you explain what you did? Okay? Reason or make sense of the quantities. How are those quantities related? Problem solving is quantitative reasoning. Understanding the numbers and how they're related, and therefore what operation I will be using. Construct viable arguments or justify it. Prove it. How many times have you heard kids say that? Oh yeah, prove it. Well, justify what you did. Explain your thinking to me. Model, and this is modeling mathematically with a number sentence, graph, formulas, etc. And then, of course, use appropriate tools, which does include manipulatives, calculators, and later on computer systems. Attend to precision. State the meaning of the symbols and the units, being very precise in what I'm doing. Mathematics is precise. Look for and make use of structures such as patterns. Can that help me draw a conclusion, help me better understand? Look for and express regularity and repeated reasoning, which comes to repeated calculations, which will lead to a shortcut. Mathematics does not say there's not shorter ways to do it, but it needs to be mathematically sound in what we do. Bottom line, the practices that students develop during problem solving will help them understand the mathematics. Progressions. How many of you have seen the progressions? Anybody seen these? Yeah. They're available. We can give you the website to where to go. It is really a scope and sequence that identifies the domains and how they develop across the grades. Very helpful document when you're looking at curriculum and frameworks. Okay? So you need to look at these. And these are the ones that are now available. Kindergarten, the counting and cardinality, K-5, operations and algebraic thinking, and so forth. We will give you the website so you can go and see these. On March 7th of this past year, a group of education and people and business leaders and government people said, you know what? How are we going to monitor this? How can we make sure that the standards that states are the frameworks and curriculum that they're creating and the textbooks that are being printed really are Common Core? And so, because of that, there are 3 documents. One created out of the Dana Center in Texas. One created, it's called the Bush Project, that was supported by the Brook Hill Foundation, and one by Achieve. And these guide you through all of the standards, and these are all evaluation tools to look at for your frameworks and curriculums, and also look at textbooks to make sure there truly is alignment. PARC, you are a PARC state. They have released the PARC Model Content Frameworks as a guide to say these are the kinds of things we should be doing. And right now, they are up for review. Anybody, you can go in and you can look at them and you can review them. It is posted, it's going to be posted June 25th, and it will close on July 11th. PARC will update the frameworks during July with a final version this summer. And then there will be webinars that will be held to highlight the updated areas. So they're putting, once again, just like they did with Common Core Standards, putting it out there for review to everybody and say, you know, what do you think? Let's talk about this. So it's your chance to be able to make comments, and then they will come back and review those frameworks. Assessment. When the assessment first came out, there were going to be 4 tests. It is now down to 2 that you have to do and 2 that are optional. Okay? The first one is optional. It was the early assessment to be given at the beginning of the year to see where the kids were in relationship to the Common Core state standards. Just sort of that big picture, you know, where are my trouble areas going to be, that kind of thing. These are still going to exist, but they will be optional instead of having all 4. Why do you think that happened? Yeah, it's called money. Okay, giving tests is very expensive. Okay, so it is optional. Component 2 is also optional, mid-year, designed to be performance-based assessment that will provide useful feedback to teachers. It too is optional. Okay, component 3 is required. Okay, this too will be rich performance-based assessment in grades 3 through 8 in high school, administered close to the end of the year as possible, and it will focus on application of concept, skills, and understanding. So what does this tell us about our instruction? Performance-based assessment. The kids have to explain their thinking. They have to be able to write in mathematics. It will be scored by computer, but also now have 2 human reviews. That is when it gets expensive, when you have to pay for the human reviews. But what they found is, yeah, the computer can grade it pretty good, but there are nuances in there that a computer can't judge. And so that is why there has to be the human reviews. Component 4 will be required and counts towards the summative score, grades 3 through 8, end-of-year assessment. And they will be innovative, computer-based, machine-scoreable items focusing on full range of standards in mathematics. And Skip will talk to you more about the PARC assessments. What does all of this mean for instruction? When we think about reality in the classroom, what does this all look like? It means that what is being taught is changing. The hardest thing for some teachers is going to be letting go of a thing that they love to teach. that is not there. Sorry, you got to draw it. Get over it. How many times has that third grade teacher said, if I only had one more week to do those multiplication and division facts, those kids would get it. But I've got to move on to geometry. And that's why we have to continually review it. There was never enough time. So it's a good thing. It's not a bad thing. Fewer concepts, but even more time to teach for understanding. This is all good news. This is good news. Yeah, you don't have calendar time money. But you can do that as a daily routine. That's still okay. All right? But we're going to focus on the important mathematics. How math is being taught will change. Focus on problem solving and mathematical practices. Teaching new concepts through problem solving, because that's real world. You're not given a book when you go to your job that has every single mathematical problem you're going to have to solve at that job in a workbook format, and you just fill in the blank. You are given a situation for which there is an equation for which you have to be able to create and then solve. That is real world. Intervention and RTI needs to be embedded. We cannot let a single child fall through the cracks. We need to provide ongoing intervention as we teach. Formative assessment as we teach. Don't wait until the end of a chapter or a topic. I need to do it every day. I need to know where that student is every day and provide intervention now. Because they can't do tomorrow's lesson unless they understand what we did today. That's what mathematics is. Assessments will influence instruction, not just content, performance-based, as we talked about. The kids have to write about math, and it has to start in kindergarten. Writing in math is not the same as writing in language arts. And we need to start it in kindergarten because we're teaching our kids how to write and how to think and express themselves. And of course, problem solving. I love this chart. This is from the USA Today in 1997. And it was based upon what employers said they were looking for, skills that they were looking for in their new employees. I love this. 1981, just come to work. That's the only thing that was important. Okay? 1985 to 1997, notice problem solving was at the top of the list. The list grew, but problem solving was at the top of the list. No matter what job, you had to be a good problem solver. One of our other authors, Dr. Randy Charles, has done a lot of research on problem solving. And we know that drawing a picture is one of the most effective strategies to help me make that visual representation, to help me understand what the problem is asking me to do. You're hearing a lot about bar diagrams. Singapore Math has Venn diagrams. We have a Singapore Math program. We looked at it and said they're really nice, but they're a bit confusing. They have squiggly lines on the top, on the sides, on the bottom. So we said we need to refine it and make it simpler. Because what quantitative reasoning does, and the quantitative, when we move the PowerPoint up, okay, that says quantitative reasoning under there. Understanding the quantities involved and how they are related, independent of the specific numbers. Because kids look at the numbers and the sizes and decide which computation to do, rather than understanding how they are related. And so that is also your mathematical practice number 2, making sense of the quantities. What does that look like? I love this problem. This quickly shows you. Mr. Samuel wants to buy 48 cans of dog food to give to the animal shelter. There are 6 cans of dog food in a package. How many packages of dog food should Mr. Samuel buy? Number 1, do your kids read that problem? No. I promise you they don't. What do? They look at the numbers. Then what do? They multiply. Do they multiply? What else do they do? Somebody said add, somebody says subtract. Well, if they add them, they get D54. If they subtract them, they get C42. And they're both wrong answers. Those are what we call distractors. But if I could have drawn a very simple picture, that wouldn't have happened. I know I need 48, and all they come in packages of 6. If I draw 3 packages of 6, how many cans do I have? 18, not enough. I can keep drawing packages of 6 until I get to 48, and then what can I do? I can count them, and I can see how many. Or I can say, wow, all of those are the same numbers, so I could just divide 48 by 6, and it's going to tell me how many 6s I have or how many packages. This is quantitative reasoning. Looking at the numbers, how they're related, tells me what to do to solve the problem. We're coming out with a mathematical practices kit to help teachers implement the mathematical practices in the classroom. Because what it requires is asking those questions that the teachers are saying, I don't know what questions to ask. I need some help here. So it's going to contain cards that have a single word from each of the practices with guiding questions, a poster with the questions, and a problem-solving recording sheet, and an understanding of how to develop those bar diagrams. It's going to look like this. It is in development right now. I cut the cards apart. It's going to be color-coded by each practice because I color-coded everything. And so I wanted them color-coded so visually I could quickly see which practices we're working on. On the other side will be questions to ask. I pass 3 or 4 cards out to each group of students and we're working on the same problem. And I tell them, I want you to ask each other these questions as you're solving this problem. And after you record your response on the recording sheet, and then you report back to the class your solution, I'm going to be asking you these questions to make sure that you really understand it. So we're putting the onus on the kids and getting them involved in those mathematical practices. We have created a lesson observation checklist for administrators and teacher evaluation if you're interested in it. We have one that is generic. We have one that is designed to go with our programs. So, mathematics. Not arithmetic anymore. We're talking about the big kid stuff. We're talking about mathematics. Why should we change? Because our children are our future. I want my grandkids to be successful. Yeah, I'm here to help them right now. We do math online with each other, and they're up in Anchorage and I'm in Chicago. But every single child needs to be mathematically literate. Every single child will be using it in the real world. And so we have to make sure that they are ready. Common Core State Standards, it's not a challenge. Everybody says, oh my gosh, I can't believe we're doing this again. Why? It's not a challenge, but it's an opportunity. Because we can't just think of our kids in Massachusetts or just our kids in Florida or California or wherever you are. We've got to think of our kids because they're all over this country. They move about, and everybody has to be successful. Common Core State Standards is a good thing, I promise you. And it's an exciting time in education.